Dear audience, hello and welcome back to this new video tutorial and this video series related to the discussion on hazards, risks and issues in electrical installations. Today is part 2 in which we are going to discuss more about the hazards. So as we discussed before in the first tutorial, we've mentioned that hazards are problems or a source of problem that might be translated into risk, which is in turn might be materialized into serious issues. So that's why we think that identification of hazards in electrical installations and implementing control methods to control these hazards is something very crucial to ensure safety in our projects. And here we will discuss some of the major hazards associated with the electrical installations and the proposed control methods. The first hazard that we will discuss is related to electrical shock. This is the first category of hazards actually related to electrical shock. So we can think of exposed electrical parts as dangerous and might lead to electrical shock. Overhead power lines are also dangerous and might lead to serious electrical shock. Wires with bad insulation can also lead to shock because you see, insulation in itself is not enough. We have to have the proper insulation, the good insulation that can protect people and equipment. So if you have a problem with insulation, this is a hazard that can lead to serious consequences. Electrical systems and tools that are not grounded or double insulated are also a source of hazard. So working with tools is something inevitable. We have to work with tools, but we have to make sure that these tools are properly double insulated and are properly grounded, so that whenever there is a leakage or something like this, then our RCDs will trip, or ALCBs will also trip. The control method, one of the control methods is to install residual current devices or RCDs. Before we have been using earth leakage circuit breakers, ALCBs, but now for more safety, these RCDs are more common, and we use them to quickly disconnect the power in case of a fault. Whenever there is a problem with the balance in any of the power lines or in any of the phases. Use insulated tools and equipment, and the insulation should be proper insulation. We also have to implement proper grounding and bonding, and here I'd rather remind you of this bonding on the final circuit breaker, on the final DBs or final panels. Okay, right and proper bonding between the ground and the neutral is something essential to prevent electric shock. We might talk in a separate lecture about this grounding and bonding. Please tell me in the comments if you really want something like this. Another hazard is related to arc flash. So overloaded circuits are dangerous and might lead to arc flash. Damaged power tools and equipment might also lead to arc flash. To control this hazard, we have to provide arc flash resistant clothing and personal protective equipment or PPEs to protect the personnel or the technicians working with the tools. And we have to conduct an arc flash risk assessment and label equipment accordingly. This is again a long topic. We will discuss into more details maybe when we go into the risk tutorial. And then implement safe work practices and procedures. Again, we might be conducting or recording a separate tutorial for this topic of implementation of safe work practices and procedures. Okay, this is also very important. Then fire hazards. Certainly we can say that overloaded circuits might lead to fires, and we have to be very cautious because fire can be dangerous for both personnel and also for the property. And the method or the control method includes regular inspection and maintenance of electrical equipment to prevent overheating, to install circuit breakers and fuses of appropriate ratings. This is something technical. We have to choose the right circuit breaker and the right fuse and the right installation method for these circuit breakers and fuses, so that whenever there is a problem with the tools or any part of the circuit, then these circuit breakers will trip and disconnect electricity. Also using fire-resistant materials for enclosures and cable insulations and in the vicinity of electrical installations, so that whenever any spark happens or small fire happens for any reason, this fire will not spread. It will retard the spread of the fire. Install fire detection and suppression systems in electric rooms. Then regularly inspect and test emergency shutdown procedures. Okay, this is very important. We have to have an emergency shutdown procedure. This depends on the type of project that we have. Certainly, it differs from one project to the other. Differs from household to industrial, and even in industrial and household variance would be there. So we have to evaluate the proper emergency shutdown procedure depending on the project type. Overloaded circuits. This is again a hazard. So overloaded circuits are dangerous. Usually I've seen these such circuits leading to fires and serious injuries and sometimes fatalities. So the control methods or the control method includes conducting load calculations to ensure circuits are not overloaded. So we have to do a good assignment in load calculations and calculating the load schedule, choosing the proper circuit breakers with the proper ratings and proper types, and also choosing the proper wires and cables as per the load calculations and load design. Install circuit breakers with appropriate current ratings and type also. Implement energy management systems. Then we have the explosion hazards. This might also happen. Some explosions might take place, and this is again very serious. So, like some on-site chemicals are harmful and might, because of the spark, might lead to explosions. Sometimes even leakage in gas or something like this might lead to explosion in the presence of spark or static charges. Some of the control method procedures would be to ensure proper ventilation in the areas with electrical equipment, implement intrinsically safe systems in explosive atmospheres, store and handle flammable materials away from electrical installations. Also, good grounding systems would also be helpful and required to prevent explosion hazards or to control the explosion hazards. Then the poor wiring and connection practices. So poor wiring and connection practices are also serious hazards, and we have to control them. So how to control? By following wire standards and regulations. So we have to abide by some standard, national or international standard. Regularly inspect and maintain wiring for signs of wear and damage. We have to check the insulation of the wires and even the wires themselves whenever there is a damage. Sometimes, for example, in the ring type circuits, whenever there is some cut in some part of the circuit, this will lead into overloading part of this ring circuit and might lead again to heating and fire problems. Use proper cable management and labeling to know what cable and what wire is going where, and to be able to manage these cables and wires. Inadequate training and awareness is also a serious hazard, and we have to control such a hazard by providing comprehensive training for personnel working with electrical installations, and also promote a safety culture through regular safety meetings and awareness programs. We have also display clear signage indicating electrical hazards so that people would know that this is a place where a hazard might be serious, and try to avoid such places. Lack of lockout tagout procedures, and this is again a reason or a source of hazard, sometimes also serious, and fatalities might take place, and fire might also arise because of this. So to control this hazard, we have to develop and enforce lockout tagout procedures during maintenance or repair activities. We might also record some special video for this. Provide lockout tagout training for personnel, and use standardized lockout devices so that the indications are common to people and no misconception or any confusion happens. Then we have this issue of environmental hazards. So electrical hazards can be made worse if the workers or the technicians or the personnel or the location, okay, or the equipment is wet. We know that normal water would increase the probability of the occurrence of hazards and might be risky, and in so many cases. So we have to control such a hazard by installing electrical equipment in waterproof or environmentally protected closures. We have also to consider environmental factors like moisture, temperature, and equipment selection. We have to choose the equipment rating for temperature, for example, or and how to protect these equipment from moisture. We have to regularly inspect outdoor installations for signs of wear and corrosion. And to conclude, we can say that it's crucial and important that an exhaustive list for hazards, identification of hazards should be noted and should be identified. Like we didn't do in this lecture such an assignment, and it's very difficult to do it because it depends on the type of the project, but for every and each project, hazards might be different, and we have to identify these hazards thoroughly, and based on these hazards we have to go into a thorough risk assessment, which will actually have a look at in a next lecture, maybe in part 3 of this series. Okay, for all of the specific parts of the electrical installations. Additionally, we have to have compliance with local electrical codes and regulations. This is essential to ensure the safety of electrical systems. Also adapting international codes would be a good solution also, unified codes, so national or international, but we have to care more about the national and local regulations, okay, because these are imposed by law. So we, especially when it comes to big projects and electrical work, especially. So we have to take care about this topic of abiding to the local electrical codes. In the end, I'd like to thank you for being attentive. I wish to see you soon in the next lecture or the next part of this lecture. I hope that this video was informative and of help. For similar material, please subscribe to my channel on YouTube. Please leave your comment and your suggestions for improvement. Again, thank you and see you next time.